Alright, we're going to look at predicting products of chemical reactions. To predict the products, the first thing you need to do is identify the type of reaction. Then we rearrange the atoms according to what that type of reaction would say we need to do. And then we write the formulas correctly, and it usually helps to write the names of the products and then write the formulas. Then we balance the reaction. So here we have sodium reacting with iron 3 bromide. And so a single element and a compound would make this a single replacement reaction. And so what happens in a single replacement reaction, if you recall back from our notes previously, in a single replacement reaction, one element replaces another element in the compound. But it has to be an element that is similar. And so sodium, since it's a metal, will replace the metal. Okay, so sodium is going to then combine with the bromine. And so that will form sodium bromide. So I'm just going to write down below here, sodium bromide. And then iron is going to be left on its own. And so how would we write those formulas? Well, sodium has a charge of +1, and bromide has a charge of -1, and so they already equal 0, so we just need one of each ion. So NaBr plus iron being left by itself. Now, of course, we also have to balance the reaction. So we have 1 sodium, 1 sodium, 1 iron, 3 bromines, 1 bromine. So that means I'm going to need a 3 here to make 3 bromines. But then that changes the number of sodium. So I have to multiply over here so that the sodium is balanced with a 3. Okay. Next we have carbon, hydrogen, oxygen plus oxygen. If you recall, that's a combustion reaction. And the products of a combustion are always carbon dioxide and water. Okay. So carbon dioxide and water, so we now can balance. We have 2 carbons, so we have 2 here. 4 hydrogens, we already have 2, so we multiply by 2 to make 4. Now we count our oxygens, we have 4 plus 2, so on this side we have 6. So we need 6 on this side. We already have 2 here, plus some number we can multiply times 2. So we have 2 here. What number can we multiply 2 by here to make all that be 6? So 2 plus what is 6? Right? 4. So what do I multiply by here to get 4? 2. Okay. And so here we have lead 2 sulfate and silver nitrate. So this is 2 compounds, so this is a double replacement. And so what's going to happen are the 2 positive ions are going to trade partners. So lead is going to combine with the nitrate, and silver is going to combine with the sulfate. And so here we would have to have lead 2 nitrate and silver sulfate. Okay, now I know this is lead 2 because I know the charge of sulfate is -2, so lead had to be a +2. So since lead's a +2 on the left, it's going to still be a +2 on the right. And so since lead is +2, nitrate is -1, I'm going to need 2 nitrates. So it's going to be Pb, nitrates NO3, 2. Then silver is always +1. Sulfate is always going to be a -2. Again, this has to add to 0, so I'm going to need to multiply the silver times 2. So I'm going to need 2 silvers, so Ag2, SO4. Have a plus sign in between. So these will be our 2 products. Now we balance. 1 lead, 1 lead. 1 sulfate, 1 sulfate. 1 silver, 2 silvers. So we multiply this by 2. Which means we have 2 nitrates, but that's alright because we have 2 nitrates there. And so this would be complete. Number 4, PBr3. And so this is a single reactant, so that's going to be a decomposition. And decomposition just breaks apart into elements, so it's going to be phosphorus plus bromine. Now when we break apart our elements, we have to think about what our diatomic elements are. If you recall back to the first video, we talked about diatomic elements. Our diatomic elements are the ones that make a 7 on the periodic table. If you remember, starting with nitrogen. So nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then of course we have to add hydrogen to that. Right? And so since bromine is a diatomic element, that means when it's by itself, and only when it's by itself, it requires a 2, diatomic. Okay? So then we'll balance 1p, 1p, 3 Brs, 2 Brs. So again, how do we make 3 and 2 balance? Right, we make them both be 6. So I make them both be 6. But by multiplying this one by 2, I change the number of phosphorus, so that has to have a 2. Next we have bromine reacting with iron. And so this will be a synthesis reaction, 2 elements combining. Now this is going to be iron and bromine. So it's going to be some iron bromide. Now, when you have a transition metal, if I don't tell you otherwise, you can assume it's got a charge of 2. But if I tell you otherwise, you have to use what I tell you. But if I don't give you an indication of what it is, just make it a 2. Alright, so this would be iron 2, so that's a plus 2. Bromide's a minus 1. Means I'm going to have to multiply bromide by 2. So we get FeBr2. Right, and then we balance 2 Brs, 2 Brs, 1F, 1Fe. We're done. Alright, so I want you to pause the video and I want you to try these next few. And then when you're finished, you can unpause it and I'll go through them with you. So here we have a compound and an element, which makes this single replacement. Again, the single element is going to replace the one that is similar to it. So iron forms a positive charge in a compound, and so that would be the hydrogen in this case, because the positive ion's always first. And so again, we're going to have iron, and as I said before, if I don't tell you otherwise for transition metals, assume there are 2. So iron, 2, bromide. So iron will connect with the bromide, and then we'll leave hydrogen by itself. Right? So iron is a plus 2, bromide is a minus 1, so I'd have to multiply that by 2. And so this formula is going to be FeBr2 plus hydrogen. Now, we just talked about our diatomic elements, right? And so hydrogen is one of those 7 diatomic elements. So since it's all by itself, we have to have a 2. Alright, now we balance 1H, 2H. So to multiply this by 2. 2 Brs, 2 Brs. 1 Fe, 1 Fe. And that's finished. Number 7, we have potassium permanganate and zinc chloride. So these are both compounds. And so 2 compounds is a double replacement reaction. And so what's going to happen? Potassium is going to combine with chlorine, and zinc is going to combine with the permanganate. And so what would be the names of those? Be potassium chloride and zinc permanganate. Alright, so we find what's the charge of potassium. It's in group 1, so it's plus 1. Chloride, minus 1. So that adds to 0, so we just have 1 of each. So we have KCl. Plus zinc is always a plus 2. Permanganate we find on our polyatomic ion chart. It's a minus 1. That does not equal 0, so we'd have to multiply by 2. And so here we would have zinc permanganate MnO4 in parentheses add 2. Now we balance 1 potassium, 1 potassium, 1 permanganate ion, 2 permanganate ions. So we need to multiply this by 2. Well, that now changes our potassium to be 2, so we need to multiply potassium by 2 over here, which then makes 2 chlorides, but that's alright because we have 2 chlorides here, and then 1 zinc and 1 zinc. and this is balanced. Alright, number 8, we have only one reactant, so the only thing it's going to do is decompose. So that's decomposition. It's going to decompose into the elements, manganese and oxygen. Again, we have to think about our diatomic elements. Are manganese or oxygen on our list of diatomic elements? Yes, oxygen is. And so since it's all by itself, it's got to have a subscript 2 because it's diatomic. We balance 1 Mn, 1 Mn, 2 O2, 2 O's, 2 O's. Okay, next we have oxygen and carbon, hydrogen, oxygen. So we have this combination, that's a combustion reaction. The products are always the same, carbon dioxide and water. We can balance. Again, I suggest balancing with your carbon first. So 5 carbons, we would have 5 here. 12 hydrogens, to get 12 here we would multiply by 6. Now we add our oxygens, we have 10 plus 6 gives us 16. Here we already have 2. Right, so to make 16 we're going to need how many? 14 more. And so what number can I put there to make 14? Right, 7. And this is balanced. Next, H2O2. This is actually hydrogen peroxide. And it's one compound, so the only thing you can do is break apart, and that's decomposition. So break apart into hydrogen and oxygen. And both of those are on our diatomic list, and so since they're by themselves, they need subscript 2's, and it turns out to be completely balanced. Right? Alright, that's all for today.